Welcome to Giang Mystery Hub, where we embark on a spectacular cosmic journey to explore the strange history of our universe. Today we uncover the incredible life cycle of stars, from the violent primordial monsters to the cold, silent end of time. We will travel through three distinct eras, witnessing the birth, the madness, and the ultimate death of every shining star. Let us journey back to the very beginning, a chaotic time when the first giants emerged from the deep primordial darkness. In this absolute darkness, the population 3 stars awakened, composed entirely of pure primordial hydrogen and helium, without any heavy metals. These ancient giants were hundreds of times more massive than our sun, burning with a ferocity that we cannot comprehend today. Because they were so massive, they lived fast and died young, burning through their fuel in just a few million years. Their violent deaths seeded the universe with the first heavy elements, paving the way for the planets and life we know. But in these early days, another type of monster may have existed, powered not by fusion, but by mysterious dark matter. We call them dark stars, though they were not dark at all. They were radiant giants, puffed up by strange energy. Instead of nuclear fusion, these stars were powered by the annihilation of dark matter particles deep within their massive gaseous cores. They could grow to be millions of times the mass of our sun, appearing as cool, bright clouds across the cosmos. Eventually, the dark matter fuel ran out, and these ghostly giants vanished, leaving behind only massive black holes in the dark. From the remnants of the early universe, an even more terrifying object formed, known to astronomers as the devouring Quasi Star. Imagine a star that contains a black hole at its very center, eating the star from the inside out constantly. The energy from the feeding black hole kept the star inflated, creating a delicate balance between gravity and the force of destruction. These monsters were the brightest objects in the universe, shining with the intensity of 1 billion suns for a brief time. Inevitably, the black hole won. The star collapsed, leaving behind the seeds for the supermassive black holes we see today. Now we move to the realm where physics breaks down, exploring stars that exist on the very edge of total madness. It begins with neutron stars, but under extreme pressure, they can transform into something even denser and far more dangerous. When the pressure becomes too great, the neutrons themselves are crushed, dissolving into their fundamental components known as quark matter. This creates a quark star, a hypothetical object where matter exists as a dense soup of free-flowing up, down, and strange quarks. Some theories suggest these stars emit strangelets, particles that could convert any matter they touch into more strange quark matter instantly. If we go deeper, we might find the electroweak star, where the electromagnetic and weak nuclear forces merge into one. Here, the core is no larger than an apple, yet it contains the mass of huge planets, defying all logic. But what if a star was completely invisible? Enter the Boson Star, a cosmic ninja made of transparent dark matter particles. These stars are made of bosons, particles that can occupy the same space, making the star transparent and impossible to see. You could fly a spaceship right through a boson star and feel nothing but a strange gravitational pull tugging at you. Sometimes, the madness comes from a collision. Imagine a red giant swallowing a neutron star whole, creating a hybrid monster. This creates a Thorne Zytkow object. The neutron star lives inside the red giant, churning its core and creating unique heavy elements. It looks like a normal star from the outside, but inside, it is a parasitic relationship that produces elements found nowhere else. These hybrids are the alchemists of the universe, forging rare isotopes that act as fingerprints for astronomers hunting them down. Finally, quantum loop gravity gives us the Planck star. It suggests that black holes do not crush matter into a singularity. Instead, the collapsing star is paused by quantum effects, creating a tiny, dense star hidden deep inside the black hole's horizon. When the black hole dies, the Planck star rebounds, releasing all the information the black hole ever consumed back into space. But all fires must eventually burn out. As eons pass, the universe enters its final era, moving towards the cold end. We now enter the final chapter, a timeline stretching trillions of years into the future, where only the cold survivors remain. Red dwarfs are the most common stars. They burn fuel so slowly that they will outlive all other stars in the cosmos. Trillions of years from now, as they finally die, they will not explode, but evolve into a theoretical phase called blue dwarfs. These blue dwarfs will be the last main sequence stars to shine, casting the final light before the universe goes dark forever. Once their fuel is gone, they collapse into white dwarfs, dense corpses of stars that slowly cool down over quadrillions of years. This cooling process takes longer than the current age of the universe. They are the silent tombstones of a once active galaxy. Eventually, they become black dwarfs, perfect cold crystal spheres floating in the dark, invisible to any eye that might remain. No black dwarf exists yet today. The universe is simply not old enough for any star to have cooled down completely. But the story does not end there. In the unimaginably distant future, quantum mechanics will perform one last magic trick on matter. Through a process called quantum tunneling, atoms in these cold remnants will slowly fuse into iron, the most stable element. This leads to the birth of the iron star, a cold, dead sphere of pure iron floating alone in the eternal void. If protons do not decay, these iron stars will be the final state of all normal matter in the dying universe. They will drift alone for eternity, relics of a time when the universe was bright, warm, and full of life. But even they might not last forever. Quantum fluctuations could eventually cause them to collapse into black holes and evaporate away. This is the ultimate fate. A universe of cold, iron, and radiation, slowly fading into a timeless state of maximum entropy. Looking back from the end, we realize how precious our current era is. We live in the golden age of stars. We are lucky to exist right now, when the universe is lit by the fires of fusion, creating beauty and life. From the monsters of the dawn to the strange hybrids of physics, each star tells a story of cosmic evolution. Our understanding is still growing. Somewhere out there, these theoretical monsters might be waiting for us to finally discover them. As our technology advances, we may soon capture the first images of a quark star or detect the shadow of a boson star. These objects challenge our physics, forcing us to rewrite the laws of nature and expand our definition of what is possible. For now, we can be grateful for our own stable star, which gives us the light and warmth to study the cosmos. We are tiny observers on a rock, looking out at a universe filled with wonders that are both terrifying and magnificent. The story of the stars is the story of us. We are made of the elements forged in their burning hearts. Every atom in your body was once inside a star that exploded or collapsed, connecting you directly to these cosmic giants. We stand at a brief moment of light between the primordial darkness and the eternal cold. Let us cherish this time. The universe is a violent, creative, and destructive place, constantly recycling matter to create new generations of stars and planets. From the subatomic quarks to the iron remnants of eternity, the scale of the cosmos is beyond human comprehension. But we will keep looking up, keep wondering, and keep exploring the mysteries that hide in the deep dark sky. Which of these cosmic monsters do you find the most terrifying or fascinating? The invisible boson star or the cannibal quasi star? The library of the universe is vast, and we have only just opened the first page of the first chapter today. As we continue our journey into the unknown, remember that curiosity is the engine that drives all human discovery forward. The universe does not give up its secrets easily, but piece by piece, we are assembling the puzzle of existence. From the first hydrogen fires to the final iron spheres, the history of stars is the ultimate epic of nature. If you enjoyed this deep dive into the cosmos, please leave a like and share your thoughts in the comments. Your support helps us continue to create high-quality documentaries about the mysteries of space, time, and physics. Check out our other videos to continue exploring the mind-bending realities of our universe and the laws that govern it. The universe is vast and full of secrets waiting to be uncovered. Never stop looking up at the stars. Thank you for watching Giang Mystery Hub. Subscribe now as we continue to explore the infinite wonders of our universe.